All right, today we're going to look at solving linear inequalities. For vocab, our first word is inequality, and that's any mathematical sentence that contains the symbols. So we have 4 different symbols we'll be looking at. The first one means greater than, second one means less than, the third one means less than or equal to, so the line underneath equal to, or greater than or equal to. A solution to linear equation or linear inequality is any value for a variable that makes an equation true. And in this case, also making the inequality true. And then flipping the sign, and that's just a reminder, we're multiplying or dividing by a negative number, we flip the inequality. All right, so first we're going to solve these one-step linear inequalities. So our first step, we're solving for x for number 1. It's the same operation as when we solved linear equations, except for that flipping part. So we have x is less than 1 minus 7. So x is less than negative 6. So any value of x that's less than negative 6 will produce a true statement in our original inequality. So we could choose 0, or 0 is greater than that. We could choose negative 10, negative 7, negative 100, and that will produce a true statement. All right, for 2, we have d minus 8 is less than 2.2. So to isolate d, we'll add 8 to both sides. So we get d is less than 10.2. And once again, any value of d that's less than 10.2 will produce a true statement in our original inequality. All right, 3, we are going to be dividing here. We have negative 4 times x, which is less than or equal to 8. Same operations when we solve an equation, except this one, since we're multiplying or dividing, we're dividing here by a negative 4, a negative number, that sign, our inequality, is going to change from less than or equal to greater than or equal to negative 2. So any value of x that's greater than or equal to negative 2 will produce a true statement. So we could use the x value negative 2, we could use x value negative 1, 0, 1, 2, 3, 4, and so on. All right, and 4, we have p divided by 2, or p over 2 is greater than or equal to 12. So for this one, we're going to be multiplying both sides by 2. Since we're dividing by 2, our inverse operation is multiplication. So we will get p is greater than or equal to 24. Now the sign here does not change since we multiplied by a positive number. If it was negative, then it would flip. All right, let's get to some multi-step equations. Once again, the same type of setup as when you're solving a multi-step equation for inequalities, with the exception you're going to have an inequality instead of an equal sign connecting your two statements. All right, so 5, we have 4 open parentheses, x minus 10 close parentheses, is greater than or equal to 36. So we have a few different approaches we can take here. One approach, you could divide both sides by 4. A second approach, you could distribute the 4. I'm going to go ahead and divide both sides by 4, but keep in mind either way is correct. The 4's divide out, so we're left with x minus 10 is greater than or equal to 4 goes into 36 9 times, and now we're going to add 10 to both sides. So we get x is greater than or equal to 19. All right, for 6, we have 10d minus 9 is less than 15 plus 4d. So we want to get all our like terms on the same side. So we want that negative 9 and 15 to be on the same side. So I'm going to go ahead and add 9 to both sides. And once again, going back to those properties that we looked at, this is using the addition property of equality. So we're balancing that inequality. So we get 10d is less than 24 plus 4d. I'm going to move the 4d over by using the subtraction property of equality. The 4d's cancel out on the right, and I'll be left with 6d is less than 24. Now divide both sides by 6. So we get d is less than 4. Now once again, we didn't flip the sign since we divided by a positive number. If it was negative, then we would flip the sign. All right, here's some more multi-step equations and some compound, and these are a little bit more complex. So the 7, we have 7y plus 4 is greater than 4, open parentheses, 3y minus 2, close parentheses, plus 1. So for this one, I am going to distribute the 4 to the two terms inside the parentheses. 4 times 3y is 12y, 4 minus 2 is negative 8 plus 1. So I use my distributive property of equality. And now I'm going to combine the like terms on the right side. So I'll have 12y, negative 8 plus 1 is negative 7. Now I'm going to move so my like terms are on the same side. So I'm going to subtract both sides by 4. 7y is greater than 12y minus 11. And then I'm going to subtract both sides by negative 12y. So 7y minus 12y, we get negative 5y is greater than negative 11. All right, now I'm going to isolate the variable y. Since I'm multiplying y by negative 5, I'm going to divide both sides by negative 5. Now here, since I'm dividing by a negative number, this is going to become y is less than positive 11/5. So any value of y that's less than 11/5 will produce a true statement in the original inequality. All right, let's take a look at one with fractions. So once again, the first thing I'm going to do is move my like terms on the same side. So this is positive 4, so I'm going to subtract both sides by 4. So I'll get negative 3/2 m is less than or equal to negative 10 plus m. Once again, I want my m values together. So since I'm adding m on the right side, I'm going to subtract m from both sides. That m cancels out. And this is, we have less than or equal to negative 10. All right, let's take a look at negative 3/2 m minus m. Think of that as minus 1m. That 1 is understood to be there. So let's just take a look at our coefficients up at the top of how we would approach this. When you're subtracting a fraction and a whole number, place your whole number over the denominator 1. So I'm going to write this as negative 1 over 1. Now when we subtract or add fractions, we have to have the same denominator. Our least common multiple of our denominators, our least common denominator of 2 and 1 is 2. Now the first fraction already has a denominator of 2. The second fraction, I'm going to multiply 1 by 2, but whatever we do to the bottom, we have to do to the top. So now I have negative 3/2 minus 2 over 2. The denominator will remain 2. Keep in mind you don't change the denominators. The numerators is what the numerator is going to change. Negative 3 minus 2 is negative 5. So I get negative 5/2 m is less than or equal to negative 10. All right, now I need to multiply both sides by the same value. Since we're multiplying our variable by a fraction, we're going to multiply by the multiplicative inverse, the reciprocal of our fraction. So the reciprocal keeps the same sign, so it's still going to be negative, and our reciprocal will be 2/5. So we're multiplying both sides by negative 2/5. Keep in mind that negative 2/5 times negative 5/2 will become positive. We'll get 10 over 10, which is 1. So we're just left with the m isolated. Now since we multiplied both sides by a negative number, our sign is going to flip. So this will become m is greater than or equal to, we have negative times a negative, which will be positive. Think of that over 10. So we have 10 times 2, which is 20 over 5. So m needs to be greater than or equal to 4. So once again, any value of m, 4, 5, 6 that meets the parameters m is greater than or equal to 4 will produce a true statement in our inequality, the given one. All right, now we're going to translate the verbal phrases into an inequality. Then we're going to solve the inequality. So we're told the quotient of y and negative 12 is greater than or equal to 36. So we're given the variable, we're given our value, greater than or equal to is that sign, and then it's going to be greater than or equal to 36. Now when we set that up, that 36 is going to be on the right. We write it in order as what we're given. So the quotient of y negative 12 indicates we're dividing. Since y is mentioned first, that's the part we're dividing. And we're dividing it by negative 12. So we can write it as y over negative 12 is greater than or equal to 36. Or you could also write it as y and use the division sign. So either way is acceptable. Now to solve this, I'm going to be using this first one. So I'm going to multiply both sides by negative 12. So I get y, once again, so the multiplier divided by negative number. We're going to flip the sign. 36 times negative 12 is negative 432. All right, number 10. This one's going to be a compound one. So the sum indicates we're adding of 4x and 2x is less than, so there's our sign, the difference, that indicates subtraction, of 5x and 13. So our first part on the left, keep in mind, we're adding 4x and 2x, and that's less than the difference of 5x and 13. All right, I apologize. I had a few technical difficulties. So once again, the sum of 4x and 2x is less than the difference of 5x and 13. So 5x minus 13. All right, so to solve this, first combine our like terms on the left side. So we'll get 6x is less than 5x minus 13. Then we'll subtract 5x from both sides. So we'll be left with negative 1x, or negative x, is less than negative 13. And that will be a positive x, excuse me. So x is less than negative 13. All right, hope you have a great evening. I will see you in class tomorrow.